Hello students, welcome back to Physics Marathon class. This is for AIATS Plus. AIATS Plus stands for Personalized Learning for Ultimate Success. And this is a very fine initiative by Aakash for all the NEET aspirants. So today we are here to understand some of the basic concepts of physics and with the help of numericals, how we can attain a good score in NEET 2025. So myself, Puneet Kathuria, your physics faculty at Aakash. So let's start with the process. So bacho, this is basically for AIATS Plus and this is the first mock test that happened on 19th January and this is for the phase 2. So what all topics will be covering in this NEET Physics Marathon part. So let's review the topics. So these topics primarily revolve around electric charges and fields, electrostatic potential and capacitance, then units and measurement, motion in a plane, and finally this is covering mechanical properties of fluids. So for today's session, these topics will be covered with the help of your AIATS Plus Phase 2 Mock Test 1. In this episode, in this session of your physics marathon part. So let's start with the questions. The angular speed of Earth around its own axis is. So first we understand this angular speed. Basically this is a part of your 2D motion. So this is a part of your 2D motion. So whenever you have a circular motion, so in this circular motion, we have a concept of angular speed. So this basically angular speed is angular displacement per unit time. This angular speed is basically a vector quantity, so we can call it as an angular velocity also. So here we will keep the magnitude angular displacement per unit time, and if you look at the angular displacement, that is in theta, that is defined in terms of radians per unit time, and that is in seconds. So we are talking about radians per second as the angular speed. And you know, this angular speed, radians per second, is defined for this circular motion. So if you complete this circular path, the complete circular path, so how much angle you will be covering, how much angle you will be traversing in this complete circular motion, and that is 2 pi radians, that is complete angle. And the time taken by the particle to complete one round, one circle, one circular path, that is called its time period t, and that has to be in seconds only. So for the seconds part, I am writing SCC. I hope we have understood this much. Any doubt? Now let's move forward with the actual question. So we have to find out angular speed of Earth around its own axis. We know Earth is rotating about its own axis. So do we have an idea how much time? Because formula we have already obtained. Formula we have understood, that is 2 pi by t. So what is basically the time period? So when you say time period for rotation of Earth about its own axis, do we have an idea? Any idea? Yes, that is 24 hours. But your formula for the angular speed says 2 pi by t, and we have just observed this time has to be in seconds. So, but for the Earth's rotation, time period that is known to us is 24 hours. So, we need to convert this to seconds. Sorry. So, this is 2 pi and 24 hours. So, in 1 hour, how much time we have in seconds? So, convert it into minutes. So, multiply it by 60, that would give you time in minutes, but we have to reach in seconds. So, we need to multiply it with another 60, and that completes this part. So, this goes with this, so it makes it 12. So, this is 432, and this 2 zeros are there, and this is. So, this is the complete answer for the angular speed of Earth about its own axis, and unit wise, that is radians per second. For the radians, we are writing RAD and seconds SEC. So, this is the complete. So, this is pi by 432 by 432 00 radians per second. So, that is the answer for this. So, this is the question, this is the actual question. So, we have built up the concept also based on the same. We have just attempted one numerical. Now, if I give you one more numerical, let's suppose if I give you another numerical, let's consider the example of a clock. So, in clock we have 3 hands of a clock. One is R hand, and how much time this R hand takes to complete one round. Do we have an idea? This is 12 hours. And then we have minute hand, and its time period is 60 minutes. And then we have seconds hand, and it takes only 60 seconds. So, once we have an idea about all the 3 different, and you know this type of question has also been asked in your PYQs. So, if I ask you what is the angular speed for the R hand of a clock, so answer goes the very same. So, for all the 3 you have to apply the very same formula. It's 2 pi by T. So, but you have to be very particular, this R needs to be converted to what? Converted to seconds. So, for the first part, so that is 2 pi by 12 into 60 into 60, and unit wise it goes the same way. For the second part, this omega is again 2 pi by, because this is already in minutes. So, 60 minutes multiplied by 60 seconds, that would give you the answer for this one. And for the third option, so this is 2 pi by 60 only. And for all the 3, units remains same, that is same for all the 3, that is radians per second. So, if the same question is being asked for all these 3 different hands of a clock, then how you would be solving this? So, this is the complete explanation. Any doubt based on this? Any doubt you have? So, this is one of the simplest concept we have understood. So, if you are done with this, if you have understood this, so shall I move forward? Shall I move ahead? Fine. Now, so this was all about this motion in 2D concept, that was for the angular speed. Now, we have another question, that is again continuation of your motion in 2D, that is motion in a plane. Now, what this question says, initial velocity of a particle is 2I. The unit wise we can assume it as meter per second again. So U is given to you as 2I, and that is in meter per second. As you can see, this UI initial, this is basically the initial speed. So it has only I component. If it has only I component, it means the x component of this initial speed is 2, and as such there is no y component of the particle. So particle is moving purely along x-axis, but it is being acted by an acceleration that is 4j meter per second square. So your acceleration is 4j meter per second square, and yes, we can understand it from the j component, j vector. So that stands for y component. So its x component is primarily 0 and its y component is given to you as 4. Unit wise again the same concept, that is meter per second square. So this is the given situation we have. The speed of the particle after 0.5 second. Now time is also given to us as 0.5 seconds. So we have to find out the speed part. Because the particle has initial x component and it is acted by a y component acceleration. So it means, let's check. This is already a two-dimensional concept. So let's understand using the equation, because acceleration is a constant quantity, that is the uniform acceleration is there. So we can purely use your equations of motion for uniform accelerated motion, and this says v is equal to u plus at, because this equation we can use it under one condition only, and that is for uniform accelerated motion. And acceleration being a constant quantity that is along y-axis only, and that is constant in magnitude as 4, it means we can make use of this equation v is equal to u plus at. But we already have separated these two components very clearly. So how you will find out the x component? X component is given by the same expression, but we'll be considering only the x variables. So what is ux? Ux is definitely 2, that is there. Is there any ax? There is no ax, so this part is 0. So we have Vx only as 2. Simultaneously, can you find out Vy also using the same formula for the uniform accelerated motion, but this time we'll be separating the y component, we'll be finding the y component of this velocity. So what is this Vy? Is there any Uy? No, there is no Uy. So this part is 0, but definitely Ay part is there. This Ay is given to us as 4. And what is the time? Time is 0.5 second. So your Vy again comes out to be 2. So if I ask you the complete velocity vector, understand it, because the same question, the same concept, we can use it to answer the varieties of other numericals also. So let's understand, if I ask you the velocity, so how you'll write down? The x component of this is 2. So shall I write it as 2I cap? And if I ask you to put down the y component, so that is yj, and keep it in standard SI unit as meter per second only. So this is the complete velocity vector. But your question is asking for speed, and we know how to find out speed, that is magnitude of this. So this is x component square plus y component square, the whole under the root, and that gives you 2 root 2 meter per second. So this is the actual question, and we got the answer as 2 root 2 meter per second only. So this was the actual question, speed. But we have got the velocity vector also. Now, if I ask you something more on this part, so let's continue with the same data. So this is 2I cap plus 2J cap meter per second only. And you know, if I ask you what this velocity vector is making with the x-axis, it means I am talking about the inclination. I am asking about the theta. At what angle this velocity vector is inclined to x-axis. So if you look at this, so this is your velocity vector, which is basically 2I cap plus 2J cap as per the given numerical values selected or given in the question. So my question to you, because this is, we have assumed it as x-axis and y-axis, so my question to you is this theta, this something can be added to the same concept. So how you will find out this theta? So if you understand this vector, so it has x component as 2I cap, so this vector is of length 2 and this is 2J cap, so this length is also 2. So now look at this, lengthwise this is 2, this is 2. I am asking you about this angle. So can you make use of your trigonometry for this part, that is tan theta, and tan theta is your perpendicular, that is y component, by base, that is x component. So this is 2, this is 2, and this comes out to be 1. So when I write down tan theta as 1, the obvious value of theta, inclination, comes out to be 45 degree. It means we have understood one more concept from the given data. So this is basically the same concept we have asked you in a different way also. So if the same numerical data is presented to you and you may be asked to find out what this velocity vector is making with the x-axis, so we got the answer as 45 degree also. And this was the velocity vector. So now, whatever we have covered, any doubt from this part, any concept, or shall we move? So Ayushi has given 45 as the correct answer. That's good, Ayushi, keep it up. So shall we move? Okay. Now we have the next concept and we'll be building up the same way what we have been doing it. So what your question is asking for, if angular displacement of a particle as a function of time is given to you as theta equal to a plus bt plus ct cube, then its angular velocity as a function of time. Now the best part is, this is what we have just covered in the very first question when we actually understood the concept of angular speed or angular velocity. Now the same question is being there in a different format. So your angular displacement is what? Angular displacement is given to you as a plus bt plus ct cube. So this is the question where your a, b, c or are assumed to be let's say positive constants. So this is the given information, and as we can see, this angular displacement is function of time. It means your particle's angular position is changing with respect to time. So this is basically again the concept of more or less a sort of a circular motion. When particle is traversing through the circular path, its angular position or displacement changes with respect to time. So your concept of angular velocity, because this is velocity, they are talking it as a vector velocity. So this is now as a function of time, then it's angular velocity. We know angular velocity is rate of change of angular position with respect to time. And when you write down d theta by dt, so basically this is what? This is in physics understood as instantaneous rate of change of angular displacement. I am writing displacement as DISP with respect to time only. So this is basically the instantaneous rate. So it means this is instantaneous angular velocity also. So the other name given to the same concept or the other type of concept which can be there, that is called instantaneous rate or instantaneous angular velocity. So now we have understood. So what is there is we have to just differentiate, because we understand this d theta by dt as derivative of theta with respect to t. So I think this is very much clear to every one of us. Yes. So it means for this angular velocity d by dt, so we'll simply put the value of theta in terms of the given equation a plus bt plus ct cube. A we have already assumed it, or that is defined as a constant in the given situation. So the derivative of constant part is 0, but for this part b being constant will not participate. So this is dt by dt plus c being constant will not participate. So this is basically dt of t cube, d by dt of t cube. So b being a constant, what is the derivative of t with respect to t? That is 1. And c being constant, what is the derivative of t cube? That is 3t square. So that is the complete answer. So b plus 3c t square. So b plus 3c t square. So that is your option. So option number 2 is the correct answer for this. I hope we have understood this. Anything else? I would like to add one more concept based on this, but that I'll be dealing it as a generalized concept. We know theta is a function of time. Your theta varies with respect to t. If I ask you, earlier we have understood the concept of instantaneous rate. Now I am asking about the average angular velocity. So that I will be giving it to you as the formula part only. So it means that is the total change in the angular position with respect to total change in the time interval. So this is the concept of your average angular velocity, what you write it as delta theta by delta t. And if you understand this, the basic concept, if you put delta t tends to 0, if you put this condition as a limit, so it means your delta theta by delta t under the same condition will define it as d theta by dt, and that becomes your instantaneous rate or instantaneous angular velocity. So this is one more point which needs to be noted for this kind of or this variety of question. So if they ask you the average concept, then you have to go by the formula theta 2 minus theta 1 by t2 minus t1, and if they ask you the instantaneous rate, which was the actual question, its angular velocity as a function of time, that was defined it as instantaneous rate. So in that case, you simply go and differentiate your function with respect to t, and that probably will give you the angular velocity. Any doubt, anything else you would like to confirm? I hope you all are getting it. So shall we move? Fine. Now, the next question is also quite interesting, and this is from a different topic now. So this is and unit and dimension. So dimension is again a very important topic, and I must say this is a topic which is of utmost importance in your NEET. Probably you will have one or two questions probably from this unit itself, unit and dimensions. So shall we, which of the following pair has same units? Now, whenever you have this kind of question, it's quite easy to answer if you have memorized all the dimensional formulas. So whatever physical quantities you have, probably you have 118 to 120 total physical quantities listed in your syllabus of your +1, +2, that is for the complete NEET part. So if you can memorize all these, rather I would rather suggest you, because initially you have to memorize, but with the period of time as you progress through your academic journey of your +1 and +2, so you come across all the basic formulas and you tend to memorize all this with your written part and regular practice. So which of the following pair has same units? So shall we move? Energy and power. So you know, I'll be writing down the dimensional formula of all the physical quantities listed in the given question, and you can pick up the answer from there only. So first one is energy. So for the energy part, I am using the word E. So energy is mL square T minus 2. So this is 1. For the power part, what is the dimensional formula? Power is, yes, what is power? Work done per unit time, that is rate of doing work. So work done is same as that of energy. So mL square T minus 2 per unit time. That is dimensional formula for the power. Angle. Now if I write down angle, is there any dimensional formula for the angle, or is there any unit for the angle? These are two different points. Now for the unit part, we have just understood in the previous question, angle is defined in terms of radians as its SI unit. But in terms of dimensional formula, this is dimensionless, M0, L0, T0. And what is relative density? Now what do you mean by relative density? Whenever you define density of any material with respect to a reference is taken as density of water at 4 degree, because at 4 degree water has the maximum density. Numerically, you can understand, you can remember this formula as 1 gram per cubic centimeter, or maybe 1000 kilogram per cubic meter. So whenever you define density of any material with respect to the density of water, so relative density is again what? Dimensionless unit. So this is dimensions, but the question is about the unit part. So for the unit part, what is the answer for this? What is the unit for this is? Joules. And what is the unit for the power? SI unit we are asking. Watt. So dimensionally and unit wise you can see both, and dimensionally it is not there, but unit wise it has an angle is defined in terms of what? Radians, and this is density of any material with respect to your reference density. I am writing a general word, reference density, and you know this reference density is again density. So it has no units, and in fact dimensionally is also not defined. Then impulse and momentum. So impulse, force which acts for a very short duration of time, that is called impulse. So what is dimensional formula for this is what? mLt minus 2 and this is T. So this is mLt minus 1. This is in terms of dimension, and unit wise this is Newton into seconds. So this is as far as the units are concerned. Then the next one is momentum. Momentum is mass into velocity. So this is kg meter per second, and dimensionally this is mLt minus 1. And you know, impulse is also understood as change in momentum. So impulse is also defined as change in momentum. So impulse and change in momentum are almost the same concepts. So it means unit wise also they should have the same units, and if you convert this Newton into second, we can write down it as kilogram meter per second also as what? As momentum. So this is the correct option. Let's explore the fourth option also, stress and strain. So in terms of units, stress is force per unit area, so that is Newton per meter square, whereas your strain, that is change in dimension by original dimension, so it has no units, no dimensions even. So the question was which pair has the same units, so your answer is impulse and momentum. So bachcho, this is a very quite interesting case where you can pick up all these questions very quickly, very fast. If you know the dimensional formula, if you know the units, so I would rather again suggest you, if you can memorize the formula chart, the dimensional formula chart with their SI units that is given in every book, the very first unit of your NEET syllabus. So I would rather suggest you please memorize as many formulas as you can. And you know, this list not only helps you to solve the unit or the dimension based question, rather this formula chart will help you to solve maximum numericals also, because at least this way you will retain all the important formulas which are involved or which are required for your NEET +1 +2 part. So I hope we are clear on this part also. Any doubt? Anything else? So I think we should move on. Now, an electric dipole is placed in a uniform electric field. Which of the following is correct? So this is something very important case. An electric dipole placed in uniform electric field. Which of the following is correct? Now, let's understand. So I'm drawing. So uniform electric field. So uniform electric field concept, all these parallel lines are basically representing a uniform electric field region. And let's place one dipole, may be placed at an angle theta. So this may be positive charge or this may be negative charge, and they have a dipole length as A. So this is the concept. So what is the situation? Now, positive charge will experience this way, because electric field is directed along this way. It means this is the positive region and this is the negative region. So electric field is always directed outward from the positive charge and it goes radially inward in the negative charge. So this is how. So it means this end of the dipole having the positive charge will experience a force like this, and this way it experiences a force like this. As you can see, these two ends of a dipole they are experiencing equal and opposite forces. So your question is a dipole that is placed in a uniform electric field. So if I ask you what is the net force experienced by dipole? So as you can see, these two forces are basically equal in magnitude, opposite direction. So as a dipole, as a system, the net force acting on the system is 0. So this is the concept. So we have understood which of the following. The net force on the dipole must be 0. Yes. Net torque. So let's understand, do we have the concept of torque? So torque, so when you will have a torque, these two forces, though they are equal and opposite, but their lines of actions are different. So it means what? So they have a tendency to, yes, turn this dipole. They have the tendency to rotate this dipole, and this torque is given to you as PE sin theta. So definitely torque is there. Torque, when the torque would be 0, if you have theta as 0, so theta is what? So we have understood theta as what the dipole is making with the electric field. So if theta is 0, torque is 0, and for another theta, that is 180 degree, torque would also be 0. So these are the positions when you will have torque as 0, and this position, the very first position, corresponds to the stable equilibrium, and the second position corresponds to the unstable equilibrium, because here we have the potential energy as minimum, and in this case the potential energy is maximum. So net torque must be 0? No, because there is no standardized condition given to us. Net force on dipole must be non-zero? No, that is not a situation, because the electric field is uniform. So we have to be very careful while answering this question, because electric field is given to you as uniform. So this net force is 0 only in case of uniform electric field. Net torque must be non-zero. So must be, it means these two conditions, if they are there, so torque cannot be even non-zero, so torque can be 0 also. So the appropriate answer is net force on the dipole must be 0. So that is the situation. I hope we have understood this concept. Now let's suppose if I add on, if there is non-uniform field. So if you place the same dipole in non-uniform field. So in non-uniform field, these two ends at one position may experience some net force, because the electric field at these two positions, at these two ends of the dipole, may be different. So in non-uniform field, force may be there, yes or no. So यहाँ पे in this situation net force was 0, but in this situation this net force may not be equal to 0. So this is the situation. We have to be very particular while answering. So we have to understand, when there is a case of uniform electric field, net force has to be 0. If there is some non-uniform concept, then there may be a force. So but in general case, we simply say in non-uniform field, this force may have some value or non-zero. So this is the same numerical we have in your AIATS plus. So shall we move? Yes. So the next question is again from the unit and measurement part. So this deals with your error part. So what this says, if percentage error in the measurement of a side of a cube is 2% and in its mass is 3%, the maximum percentage error in the measurement of its density is. So this is quite easy situation. So first we need to understand the density. So what is the general formula for the density? Density is mass per unit volume. So for mass, I'm writing as m for the volume. Now we have a cube of side. So what is the volume? Volume of a cube is side cube. And let's suppose if I call this side as L. So that means ml cube. That is the standard formula for the density. And you know, now question is about the error part, the maximum percentage error in the density. So maximum percentage error in the density. So mass has power 1, so it has 1 times percentage error in mass, plus your length has power, or this is 3. So this is 3 times percentage error in length. So that is a standardized formula from the error part, and this is how we'll calculate the maximum error in the measurement of density. So in the mass, what is the percentage error in mass? So that is 3%. So 1 into 3, that makes it 3%, and that is being contributed by your mass only. Then length, for the length, it has a contribution 2%. So 2% into 3 will make it 6%, and the overall density percentage error will come out to be 9%. So let's check. So this is 9%. I hope we have understood this. Any doubt, any part which you would like me to repeat or you would like to ask? Shall we? Fine. So I'm moving ahead. So the next question is again from a very interesting area, that is from the capacitor part. So what it says, C is the capacitance of a parallel plate capacitor. So we have a parallel plate capacitor. If the separation between the plates is halved and plate area is doubled, then the new capacitance becomes. So before we attempt this situation, let's understand for parallel plate capacitor. So for the parallel plate capacitor, the formula for C capacitance is A epsilon naught by D, where A is the area of the plates involved. So this is the positive plate and this is your negative plate. They are separated by this distance D, and epsilon naught suggests, so this capacitor has, this is like a free space or a vacuum that is there. So this is the formula. So the next question says, if the separation between the plates is halved. So initially we have assumed the separation as D. So in the second situation, if the separation is reduced to half and the plate area is doubled, so area becomes 2A, keeping the same medium intact as free space only, the new capacitance becomes, let's say, C dash, and we have to answer it in terms of C only. So the best way to deal with this kind of numerical is always go with this ratio. So this A epsilon naught D cancels with this 2 comes out at this position. So this is 1 by 4, and we have to find out C dash when you multiply this with this. So it gives you 4C. So it means your new capacitance becomes 4C. So this is the simplest of all. Now let's move to another new concept keeping the same capacitor topic. So let's suppose if I fill this gap with some medium and its dielectric constant is K. Now this is no more a vacuum or a sort of free space capacitor. Now it is being filled with some dielectric whose dielectric constant is given to you as K. So for your knowledge sake, I am giving you the new capacitance. The new capacitance, I am putting it as C prime for this situation also, and that becomes K times the original one, and keeping everything intact. So it means if you fill the gap between these two plates with some dielectric constant, then new capacitance would get increased by a factor K itself, where K is what? Dielectric constant. So this is something more to this concept. Shall we move? Any doubt you have, you can ask. Shall we? Thank you. So I'm moving ahead. Now, this is something more. A body is projected with a speed of 4 meters per second at an angle theta with vertical. The kinetic energy at the highest point is 1/4 of its initial kinetic energy. The value of theta is. So let's understand the very same concept. So body is projected. So body is projected with some speed, maybe u, at an angle theta. So what this angle is? This angle is 90 minus theta. Do we understand? And it follows a path like this. So this is basically a projectile. So now question is, we have to observe its kinetic energy at this position, at highest point. So first we need to understand the initial speed with which it is projected is mu, this speed is u, so its kinetic energy with which it is projected is half mu square, where u is the initial speed, that is speed of projection. M, I have assumed the mass of the particle, that is a projectile. Got it? Now, if it is projected with speed u initially, what is the speed at this position? So this speed is, let's suppose if I call the x component of this is as ux. So ux would be u cos, what is this? U cos, what is this theta is? Shall I say 90 minus theta I am talking about with respect to this horizontal. The angle is given to you as with respect to vertical, that theta is given to you. So shall I write it as cos 90 minus theta as sin theta? So this is the initial speed along x-axis or the x component. What is the speed at this position? That remains as ux only. You got it or not? Initially particle has both the components ux as well as uy. But the moment particle reaches at its maximum height, its speed is ux only, and kinetic energy at this point is half m. What is ux? Ux, shall I write it down as u sin theta? So u sin theta, and when you square it, so this is the kinetic energy at highest point. So this is the kinetic energy at highest point. But your question says kinetic energy at the highest point is equal to 1/4 of the initial value. Can you understand this? 1/4 of its initial value. So if you cancel this common part, so sin square theta is 1/4 and your sin theta becomes 1/2, so theta becomes 30 degree. So this is the same angle which is given to you with respect to vertical. So this theta comes out to be, theta is with respect to vertical, comes out to be 30 degree. Do we understand? I hope. So shall we move? Any doubt? The electric flux through a spherical surface S containing a point charge Q at its center is phi. If the surface area of the sphere is halved, then flux through it becomes. And this is a very simple question. So as per your Gauss's law, what is the total flux through closed surface, that is E dot dA for the closed surface, that is closed integral, is basically charge, and this is the charge enclosed within the Gaussian surface per unit epsilon naught. So this Gauss's law clearly states this flux or phi. I am talking about electric flux, so let's put it as electric flux. So electric flux phi is independent of shape and size of closed surface. So this is the important point to be noted. And let's suppose the electric flux through a spherical surface S. So this is the spherical surface. It encloses the charge at its center. So flux through the surface is what? Q by epsilon naught as per your Gauss's law. If the surface area of the sphere is halved, so if I reduce this surface area to half, enclosing the same charge, as per this statement, the flux through this surface would still be what? Q by epsilon naught as phi only. So it means your flux would remain same. Important point, that is independent of shape and size, that needs to be noted. Shall we? Any doubt? Now this is again important. What is the reading of screw gauge shown in the figure? This is a screw gauge, and least count of screw gauge is given to us as 0.01 millimeter. So this is the important point. So least count is basically defined as pitch by number of divisions on circular scale, and this least count is already given to us, known to us as 0.01 millimeter. So this is already given to us. Now question is, how you will take the reading for this one? So the generalized formula for the reading of this instrument is, so this is mean scale reading. I am writing mean scale reading as MSR plus the number of divisions coinciding on circular scale multiply by least count. So if you look at the figure very clearly, what is the main reading? Can you see the main reading as 3 plus? Can you see the reading which is clearly shown to you as, that is coinciding with this mean scale line, that is 24, and the least count given to us is 0.01 millimeter. This is also in millimeter, that is also there in the millimeter, and when you solve it, what you will get? 3.24 millimeter as the answer for this reading. So fourth option is there, so that is how you will find out the reading of this. Shall we? Now the dimensional formula for the heat capacity. So this is quite easy and interesting, so I will be making it a quick one. So first of all, the heat given to you as mc into delta theta, this mass into specific heat, this part is basically known as heat capacity. This part is known as heat capacity. So if I write down the formula for the heat capacity, so that comes out to be m by delta theta, that is change in temperature. Sorry, this is Q by delta theta. What is Q? Q is basically the amount of heat added. So this is heat energy. So m L square T minus 2, that is the formula for the heat energy. Delta theta, that is in Kelvin, K. So can we pick up the option? M L square T minus 2. So this is not the option. This is not the option. This is also not the option. M L square T minus 2 K minus 1. So this is the correct option we have for this. So this is quite easy. So I'm moving ahead. Now we have 2 point charges. This is from your electrostatic part, electric field. Point charges plus 3 micro and plus x are placed 12 centimeter apart. So this is 3 microcoulomb and this is plus x microcoulomb. They are separated. They are placed 12 centimeter apart. Electric field intensity at 3 centimeter. So we have to find out electric field maybe at point P, which is at 3 centimeter, and from the other charge it is 9 centimeter. So electric field intensity at 3 centimeter from plus 3 coulomb, charge is 0, then the value of x. So first we need to understand the electric field due to this is radially outward. This is also positive, so this also is radially outward. So these two electric fields will mutually cancel out each other. So how you will find out electric field at point P? This is due to plus 3 microcoulomb. So this is KQ by R square. So this is R square means 9 centimeter square. There is no need to write down plus because we have already considered the radially outward direction, and it balances electric field due to the x coulomb plus x coulomb charge. So we have to basically magnitude wise they have to be equal, direction wise we have already shown them as opposite. So let's equate their magnitude. So this is x microcoulomb and this is 9 centimeter. So this is 81 centimeter square. So when you equate it, so this is 9 centimeter square goes with this one. So 9 3 27, that is the value of x, and that stands out to be in microcoulomb. So this is the answer for the microcoulomb. Now we have a question: when a sphere falling in a viscous liquid attains the terminal speed. So whenever you allow a spherical body to fall through a viscous medium, so initially it starts falling purely because of its weight, and with the speed it gains, these layers come into relative motion, relative sliding. So it experiences a viscous drag that is opposite to this, and this is F. Because this is already in a liquid, so this body will experience an upthrust also. And you know, the terminal speed is defined only after attaining equilibrium. So this is only after attaining equilibrium. It means this downward weight is being balanced by these two upward forces. It means there is no net force experienced. So the net force acting on the sphere is 0. That is probably the answer. The drag force balances the buoyant force. No, that is in the same direction. The drag force balances the weight. No, that is incomplete. The buoyant force balances the weight and the drag force. No, that is also wrong. So this is how we have to attempt this kind of question. Any doubt? Okay, fine. So this is all for today's physics marathon part from my side, myself Puneet Kathuria. Again, thanks for joining this session. So any doubt, you can comment. Thank you, Bacho. Thank you very much.